Alrighty, thank you very much. So I was supposed to be the last speaker between the good talks and beers, but now I'm between good talks and lunch, so I don't know which one is better. But, oh, sorry, I took this one. I wasn't supposed to take it. I'm stealing everything I see, so sorry. So I'm going to talk to you about open source software, weaponized as part of the compromise. And my talk will be from defensive perspective. So I am a defender, blue teamer, DFR specialist, malware analyst, and so on. So this will be from a real case I was dealing with previously. I will walk you shortly through the case first, and then I will let you know about the details about the malware. But first of all, I like to start my, oh, it's asking for permission. Oh, I don't need that one. Yeah, I'm happy with this one. All right, so first I will start with disclaimer. So I work in a big company. We have 800,000 people working for Accenture, and we have good lawyers. So I always want to say that if I say something stupid, tell stupid jokes or anything else, all the expressions are my own and all the comments are my own. So don't blame Accenture. If I tell you something stupid, blame me. It's on me, purely on me. So my name is Juho Jauhiainen. I've been working with the Accenture for the past 3 years. I've been doing 11 years of cybersecurity, mainly DFIR, malware analysis. I have a background. Before Accenture, I was working for Finnish government, NCSC Finland, and before that, some consulting as well. I have a master's degree in information security and cryptography, and even though that it says cryptography, I'm not that good in mathematics, so got it true. One thing I want to mention is disobey. So if you are ever planning to come to Finland, you should come in February, because we have the hacker conference in Helsinki. We have around 2,500 people attending the conference, good talks. For example, Chris Kubeka was there a few years ago giving a keynote. So a really good place to be if you want to participate there. But that's about me. And let's move on to the actual agenda. So like I said, I'm going to walk you through the case first, how we came up with the case, what is the story behind it. Then I will move on to the malware analysis bit. I will go through the malware analysis chain, and then some lessons learned from the case and other stuff as well. So this case took place in December last year, early December, late November, I think it started. I was pulled to the case to do the malware analysis bit of the case and figure out the timeline as well with the rest of the team. I'm not going to mention the client, and I'm not going to show you all of the juicy details, because I don't want anyone to realize which company this was, but this was this organization in Europe, and quite a big one. So, overview of the case. So, threat actor forked open source code of the KeyPass and weaponized it with malware. And I'm going to explain how they did it and what kind of changes they made to the code. Then they created a fake website where they were sharing the sample. This is one of the websites they were using, keygas.com. And there are several others. I will show a bit of them later on. But this was the one they were using in this case. And then they created a malware-tized campaign on Bing, where they were advertising this fake website. What happened in the organization? The user, they had KeyPass in the organization, so it was allowed software. They were able to use it on their daily basis. So they were storing all their company credentials to the KeyPass vaults. So they were using it. The victim was using Windows 11 system. So he or she was trying to find the KeyPass from the system and use the search bar on the left bottom corner. And the Windows 11 Cortana search bar returned, first result was the real application, which was installed on the system, and the second one was the fake website on Bing. So Cortana shows you the Bing results as well. So instead of clicking the first one, they clicked the second one and ended up to the fake website where they downloaded the malicious version and compromised their system. I will shortly tell you more about the malware, but basically the ultimate end of the malware infection chain was Cobalt Strike Beacon, which was then used for manual operation against this organization, and I will, in the end of the presentation, tell you more about the manual operation as well. So in high level, the case was like this, and let's now look at the more detailed facts about the case. So when we got the case, it started with the detection. So the client had Microsoft Defender for endpoints, E5 license, they were using it, and it detected Cobalt Strike, but it didn't detect this malware. They detected another instance of Cobalt Strike in their environment where the investigation started. It had really short dwell time, so the first alert came after 6 hours of installation, but 6 hours is still a much to do for the threat actor. In 6 hours, you can do a lot in the environment. And 30 minutes after the manual operation, so the impact wasn't that big, and I will tell you later on how big it was. In this case, we retrieved the binaries from the system using the MDE, but they were also available on VirusTotal. Not all of them, but some of them. And if you're interested to walk through the malware analysis chain, I can deliver you the samples, or you can download them from VirusTotal as well. So now to the interesting part, the malware analysis. So first of all, this KeePass installer, which was downloaded from the website, was named as KeePass 2.57 setup.exe. And it was built with the inno setup, which is the same method as the real KeePass uses for building. And if you can see, there is like all the information, here. So all the information here is like the Dominic Rachel, who is the original creator of the KeePass and so on. So everything here looks kind of legit, except the publisher, Avarcom, which I will discuss more later. A few things I want to highlight. They made a mistake. So they forked a previous version of the source code, 2.56, and renamed it to 2.57. So there's a version mismatch in the actual file and what it is saying it is. Another thing which I already mentioned is the inno setup, which is built the same way as the legit one, which makes it really easy to extract. So basically, it's very easy to see what is inside these installer files, and you can see the hashes and so on. You can compare them to the real one, and which was done in this case as well. So what I did next was to compare the real legit KeePass to this version I downloaded from the fake website. And as we can see here, many of the files have the same naming convention and even same hash values, and the comparison is done here. So we can see that all the other files except these three of their keepass.exe, conf.bin, and shinstitutil.exe match the real version. So the client actually thought that because of the malware was signed and it had all the legit files there as well, and the naming convention was real, that this is actually a real version, and something else has happened because MDE didn't identify this as a malware. So looking at this, my question was like, what are you? What are you three files? And these files are the ones that I went for manual analysis, what they do, and what kind of functionalities they have. But first, I of course wanted to take a little bit analysis how the infection chain is, and I'm not going to through this my try-hard session with taking time to analyze the malware, but I will show you how the infection chain goes. So basically, the keepass.exe was the launcher. It executed the shinstitutil.exe, which then decrypted and executed the conf.bin. And the installer, like I said, it writes several files to the disk, and most of the files are the same as in the real version. But these three malicious files, the first one is written in .NET, the second one is common C binary, and the last one is encrypted data, which after decryption becomes a CS beacon. Of course, when you are dealing with malware, I tend to run it every time and try the functionalities out, especially as this was mimicking the real KeePass. So this is a screenshot of this specific malicious version. I created my own database there, put there some passwords, some websites and notes, and then on the background took a look with Procmon what it does. And this specific file actually caught my attention. So it is actually writing a file under the app data local directory with some digits and .kp. And I was super interested, what is this file? What it does, what it contains? Is it the additional payload or something else? Nope, it's actually the clear text dump of my passwords. So here you can see all of my passwords, and which I had stored. Please don't use them; they might work. So, but anyway, so these were in the. So this is the functionality of the KeePass as well. So it actually steals your credentials, which are stored to the KeePass vault. Of course, we want to know how this works and why it works, why it does it. So let's take a look to the decompiled code. So. The binary is kind of big. For example, the main form has almost 17,000 lines, so it's time-consuming to go through the malware line by line. So I'm not going to bore you and show all of the code, but here are some pics from the code I want to show you. So, for example, the main form has 192 lines more than the original one. So there is some added functionality. And what this functionality actually does, it basically loops through the open database and writes the account, login name, password, website, and comments to a memory stream. And this is, by the way, interesting. If the password vault has 8 or more passwords, it will proceed with writing the file on the disk or something else. So if you are storing less than 8 passwords, you can use this on your daily operations. Then it writes it to the file, which I mentioned previously, so the kp file under the appdata./local. It's a random 3-number digit, so basically every time you execute it, it might be different. So it's not a good IOC, for example, to identify just based on the file name. But of course, the regex might work. Then the other stuff it does. So basically, it's creating this kind of launch parameter for the sh-instutil. And the launch parameter is hexadecimal string, which is built in the main form class of the KeePass.exe. After that query string is passed to the sh-instutil.exe, which is then launched with it and executed in hidden mode. So the user cannot see any command lines popping up. It's running on the background. And it also sets a persistence for sh-instutil.exe to ensure that every time the user logs on or the machine is rebooted, the sh-instutil.exe will be executed. So my question was, what is this sh-instutil.exe? I wasn't too familiar with KeePass before this case. Now I know the internals quite well because I have been learning the real version as well. So basically this sh-instutil.exe in the real KeePass, it installs the shell install utility. So basically helping out the Windows user so that you can open the KeePass vaults using the Windows Explorer. And typically, it only has 2 parameters. So it has install and uninstall. So it doesn't have this query parameter. And of course, the next question is, why is there a query parameter which is passed from the KeePass? Oh, wrong direction. Here we go. So I went to analyze statically the sh-instutil.exe. And here's the highlights of the analysis. So basically, the main function checks first if the binary has been started with the query parameter. If that check is passed, it will load the content of the file conf.bin into the memory and stores it to the variable. Later on, there is this RC4 key creation process, which is where the query parameter is passed, and then later on the conf.bin is decrypted using that key with RC4. Then it will execute the payload. And the execution is kind of, well, this is known for red teamers, but for me, this was kind of new one. So basically, they are using enum fonts wide character API with a callback function pointing to the start of the shellcode. So basically, when the Windows enumerates the fonts on the system, it will return to the shellcode instead of the main program. So they were trying to evade detection by using Windows native APIs for executing the shellcode without using like stuff like where they jump the code to the shellcode when it would be more easily detected by the EDR or AV. I'm lazy, so I saw this and I thought that I don't want to start implementing the same RC4 myself. I want to do it easy way. So how can I get my hands to the actual shellcode? So I went to the dynamic analysis. So basically run and dump, run the binary and dump the memory. So here's how I did it. So basically very basic stuff if you are familiar with malware analysis. So just like set breakpoints on debugger and then go to the memory section and dump it to the file. And this is exactly what I did here. So I managed to write the shellcode to the disk. And like I said before, this was Cobalt Strike. And often when we do DFIR, we always see the Cobalt Strike. I'm getting bored to the Cobalt Strike. Please come up with something new, because like every time we are seeing it, APTs use it, ransomware groups use it, everyone uses Cobalt Strike. So it would be nice to see some other C2 framework in the future as well. So basically, yeah, running against the few common Cobalt Strike decomposers, I figured out that it's using the same license ID than Black Basta ransomware group has used in the previous ransomware attacks. So very light attribution to ransomware here, because you know license IDs, when you crack the software, you can define the license ID, you can use whatever you want there. The common ones are like 1, 2, 3, 5, 4, 5, 6, 7, and 1, 3, 3, 7, and 6, 6, 6, basically. So, but this is not like some let's speak. This is something else and legit one. But of course, you have to remember that you can basically generate the license ID in Cobalt Strike. The other thing is the C2 domains. So here are the ones it was using. So it was using soinit.com and Telbull Digital, and these two domains are similar ones that the Black Basta is using. So another attribution to the Black Basta group, still a very light one, but low confidence one. And these were protected by our favorite one, Cloudflare. And I was working before for NCSC Finland, and back then we were doing a lot of abusing and takedown requests to different vendors when we were seeing C2s. And every time it was Cloudflare, we had really painful time in head, because they were really bad at responding our takedown requests, and usually they respect the privacy of the end user. And for malware, I cannot understand this, but I heard good news a few weeks ago from my ex-colleague that they are getting better and they are actually doing something for the takedown requests. But anyways, so many threat actors use Cloudflare to protect their actual infra and set it behind the Cloudflare. So, of course, this gave us some OSINT leads, and I was keen to find more campaigns related to the same threat actor or similar malware or something else. So I was like going through the what we have, and for example, the keycast.com, based on the HTML body SSD search, brought me back a lot of other domains that were used to deliver the same malware. And it would be super interesting to see how much this malware has been downloaded from the sites. But I don't know that, but at least they are doing a great job of creating new typo-squatted domains where they share this malware, and I assume that these are part of the similar malvertising campaigns as well. The next one was about the certificate, so the digital signature of the exe files. So like I mentioned in the first, the name of the company that had synced this binary was Avarcom LLC, and that's one of the OSN leads I was using. But if we compare it to the real one, we can see that they are using the open source developer signature here, and it's totally different, and this should like ring some bells when you're installing software from untrusted sources, that if the signature doesn't match the original creator of the program, it should be alerted somewhere. So how about this Avarcom LLC? So this company came back with multiple results when I was doing searches on it, and I found 2 companies with that name, and one of them is based in Uzbekistan, and another one is Russian company. So this also supports the theory of ransomware group operating from the Eastern Europe using these stolen signatures, or even companies that are made to create signatures. This kind of companies do not have business, but they usually been used to do some malicious, for example, buy global strike licenses, and etc. Unfortunately, well, I was looking, of course, the thumbprint of the signature, of the digital signature, to find out if there is other malware signed with the same certificate, to identify if they have another campaigns, another malware targeting some other open source software. But unfortunately, VirusTotal returned only these samples which were related to this campaign when I was doing the presentation. So hopefully, if they reuse this digital signature, I will get an alert, and I will see if they are using that to sign on other malicious programs as well. Then, of course, the debug file paths. So basically, when you compile a code, it will implement the debug path of the PDB file to the code. And these 2 binaries both had PDB paths. The path is on the F drive, where keypass 2.56. But unfortunately, I couldn't find any malware that was using, for example, well, the F work is kind of generic, so it brings a lot of false positives, but like with the full path under the keypass, I couldn't find any other versions of keypass which would have been weaponized with similar techniques. But I managed to find another campaign, and this is, by the way, only public blog post related to this kind of the same threat actor. But TrustWave had released last summer in June a blog post about the same group using same CS beacon, same watermark, and same TTPs while creating the malware. But instead of using KeePass or other popular software, they were using fake advanced IP scanner. And I don't think that this malware actually is that often used in the organizations. I don't think why, for example, HR or social media person would download this one software and run it in the environment. So I don't think this was so successful as the KeePass one. But anyways, instead of actually putting the malicious code to the program, they were using DLL side loading. So creating this malicious DLL, which was loaded from the same directory, and then it did the same thing, decrypted the blob, and injected the Cobalt Strike beacon to the process. So, case summary and lessons learned. So, first of all, a few things I want to mention from the case. So, it has low confidence attribution to the ransomware group. The KeePass was weaponized with password stealing capabilities as well, not just the beacon. And they were using malvertising and requires user activity. Like I mentioned before, the user was using the Windows 11 Cortana search to end up to this web page. And my question is, why Microsoft is showing these malicious ads on Cortana? We don't want them. No one wants them there. I know that they're doing business, but it would be enough if they're showing them on Bing, but not on the actual operating system. And if they continue doing this, I assume that there will be more campaigns like this it will be very effective against people who are not that savvy with IT. For example, in this case, the person who got compromised was working in the communications, social media team of the company. I'm lazy as well. Yeah. And now we come to the impact of the case. And I have to prepare you for the disappointment of the year. No lateral movement, no ransomware, no additional malware deployed. Only the KeePass credentials were compromised. Crypto scam. So, what actually happened after the manual operation? They came in late in the evening. First thing they did, they read the credentials from the app data local KB file. So they stole all the credentials in that file. And like I said, the victim, the user, was working in the social media department. This is related what happens next. So they got detected after that. So they were kicked out from the environment. So they had to move their tactics, like change them on the fly. Their goal was to do something, but now they cannot do it, so they have to do something else, which came up to the crypto scam. What they did, they created a fake NFT-themed website with crypto stealer. So basically, this fake website was the theme was of the victim, so it was looking like it would have been created by this organization, and they were saying that, hey, we have these exclusive NFTs, come and buy them before they run out. And when you went to the site, there was this crypto stealer JavaScript, highly obfuscated, by the way, but it was there, and it tried to steal your cryptocurrency from your wallets if you had the session open on the same browser. Well, how they managed to get people to their website? They had the social media credentials. So they were using the client's social media to promote this website. This client had 6,100 followers on Twitter. So it was very good campaign, and it reached many people. So I don't know the impact for the third-party victims who visited that site. If they had Bitcoins, they might not have any more. And my biggest what if here is, they did something that wasn't that interesting, the crypto scam, but my what if is that if they were not caught by the MDE, would this incident have led to ransomware? Because there is low confidence attribution to ransomware group. And to be honest, I think they would have executed ransomware in this environment, but they didn't have time to do lateral movement, enable the persistence in the environment, and so on. So they had to move their tactics. So what are the lessons learned from this case? In this case, we actually did the malware analysis faster than forensics. Before we had the laptop, we already knew how the computer was infected because we got the binaries from MDE, we saw the infection chain, we knew the facts. So it was really easy to do the forensics. So that is like why you have to always do malware analysis as well if you see malware which is related to the incident. Of course, if the client would have used MFA in their social media, they would have not been compromised by that. Their social accounts would not have been compromised. But instead of using MFA, they were using KeePass Vault with all the credentials there, which were stolen in this case. And of course, the third one is why social media team or HR or anyone should be able to download applications from internet and run them. Why should they need that functionality? We cannot always blame the users. We have to do something to make their life, well, I wouldn't say easier, but more safe, so that they know where they can download the software and they cannot download it elsewhere. And of course, the Microsoft thing, why are you doing it? I don't know. I really want to get an answer, why are you showing the malicious ads there? One last thing before I end. So this is my first time in Bulgaria. I have never been here. My colleague lives here, so I wanted to visit him. But the original reason was Vangelis took us from Greece. He actually told me I should put a CFP here and come to talk here. And he said to me that he will be here today. He will try from Greece to see my talk if I submit and get accepted. He's not here. I asked him yesterday where you are. I'm in London. I forgot. Like, dude, come on. Yeah. All right. Anyways, my name is Juho Jauhiainen, and I thank you very much. If you have any questions, I'm happy to answer them.